Welcome to the second Nexus MedTech workshop. Today we're going to be focusing on medical AI. So we'll be talking a little about the technical side of AI, talking about like kind of how like the progress that people have made in the technical side of AI, and how we can actually apply it to healthcare, and what the future of AI looks like, both within and outside of healthcare, and what the implications of that will be. And then finally, there'll be a nice section about how we can actually use AI to help us learn a bit more about medicine as well. Overall, just the goals of this workshop will be to provide a technical overview of the current state of the art of technologies. And thank you guys all for coming again. How many of you guys came last week as well? You want to put your hands up if you came here last week as well? And then first time? Just a couple of you. All right. So yeah, I'll get you guys all to scan the attendance form here. Please put down your email as well, because this is the way that we can share the slides to you guys as well. So because we want to share it to the guys who came here first, and then we'll share them around a little bit more later as well to everyone else. So hopefully through these workshops we can get you guys all interested in MedTech. Does anyone here have like a special interest in AI as well? Yeah, a few nods. Nice. All right, guys. Anyone still scanning? Well done. All right, I'm going to hand it over to Brian, Isabel, and Deepak, who will be taking you through AI.
Okay, thank you, Nathan. So I'll be starting off with a bit of an overview of AI, so a bit about me. My name is Brian. I'm currently doing my BMed Sci in Medical AI under Associate Professor Kwok Kao, which some of you may have seen around. Most of my time is spent doing AI research and projects under the Monash MedTech Lab, which Deepak and Isabella are also part of, and have a few ongoing projects with Monash Health and Alfred Health in that space as well. So here's the plan for the next 20 to 30 minutes. I'm going to start off by sort of laying a foundation of AI, giving you some background knowledge, and sort of answering the question of how we got to where we are today. Then I'm going to go over a few of the top models, benchmarks, and state-of-the-art AI today. Then I'm going to sort of set the scene for implications for medicine specifically, and current applications in medicine, before later going on to see what the future of medical AI might look like, and as well as how we can use it to learn and research more effectively. So in terms of foundations, these are some of the core questions I want to get at before we dive into what's happening today. Some of you may already know a little bit about AI, but just so that we're all on the same page, I'm going to start off really basic. So what is AI? It's essentially the creation of machines which can do tasks we normally attribute to human intelligence. So these are things like reading comprehension, things like complex decision making. Machine learning is a subset of AI. So this is the creation of programs or computers that can sort of learn from data and iterate and improve over time, not just obey whatever explicit rules you programmed into it. Further within that, another subset is deep learning. So what is deep learning? It's specifically the use of neural networks, and it's one approach to machine learning. So a bit more about neural networks. So what are they? They are a network of interconnected nodes. These nodes are arranged into different layers, so the depth of how many layers there are, that is the deep part of deep neural network. These nodes all have weights, we call them, or sometimes we call them parameters. They're essentially mathematical variables that you can adjust over time through the training data, and that allows them to transform some sort of input, whether that be, let's say, an X-ray, into an output, let's say a diagnosis. So the way they do that is through many training cycles, or we call them epochs. They learn to adjust the weights in just the right way to basically model any sort of mathematical relationship. And by doing that, they're able to transform some input that we want into the desired output. So these neural networks would become the sort of core, one of the core technologies in today's modern transformers and LLMs. But before we get there, let's talk a bit about NLP, or natural language processing. So what is it? This is a field at the intersection of computer science and linguistics. So this is focused around getting machines to sort of understand, generate, and respond to human language. And some of the common tasks that we can see here, things like reading comprehension, things like translation, text summarization, retrieval, as well as speech processing. So these are all tasks that we know that LLMs are getting better and better at. It's really good because it's able to sort of create a natural interface between us and the machine, so that everyday people, even if you don't have any coding experience, you're able to interact and get things done using LLMs. So one of the key questions at the sort of core of NLP is, how do we represent language, human language, in a computer that allows it to sort of robustly process and generate this language? Over time, let's say the last 60 to 100 years, we've had a lot of progress, a lot of different approaches to this problem. So we start with really simple rules-based approaches where people try to specify and program every rule of human language into the machine. But we notice that those sort of approaches don't work because they're not very flexible. Later on, we had statistical models, and we moved on to deep learning, so using the neural networks, and something called word embeddings, which we'll touch on in just the next couple slides. Today we have LLMs, which are really a more sophisticated, advanced application of the things that we've learned along the way. So what are word embeddings? Has anyone heard of word embeddings here? Hands up if you have. One? Okay, yeah. So what are word embeddings? They're a numerical representation of a word. So there's an example up in the top right-hand side. You can see we have man, woman, king. Is that too small? Can you guys see that? Maybe if you looked at the back screens. Essentially, each word is represented by a row of numbers. And each number, so we call those dimensions. So if there's 10 numbers in the array or the list, then there's 10 dimensions in the vector. Each number corresponds to some sort of axis of meaning. So in this diagram, we have the first number corresponding to living being. So how much man, woman, king, queen correlate to living being, the concept of living being, that is what the number represents. And then we later on have human, so all of them are high in the human dimension. We have royalty, so man and woman, not so royal by itself, so that's pretty low. But then we have king and queen, which strongly correlate to royal, so they have high values in that dimension. The way that word embeddings work is we're supposed to capture the meaning of a word within this list, and that allows us to group them together. So similar words, words with similar meaning would be grouped together when we sort of plot these numbers. So this is like a 2D, very simple visualization of word embeddings. And we can see king and queen, which are sort of more closely linked than they are to, let's say, man and woman. They are grouped together, whereas man and woman, they're grouped in a group of their own, but further away from king and queen. But you notice that also king and man are sort of grouped more on the left side, whereas woman and queen are grouped more on the right side. So that's how we sort of capture relationships within the word embeddings. This is a bigger example. So we can notice here, can anyone notice any relationships, any groups of meaning within this thing? Hopefully you guys can see that. Can people read what's there? Yeah. Can anyone just give an example of a group they spot, a group of meaning?
Gender split on top and bottom.
Yep, that's right. So let's see a lot of the female ones more on the top, male ones on the bottom. Any else?
Social distances across.
Yep. Do you wanna explain that a bit more?
Towards the left, you have more familial terms, and towards the right, you have more socially distant terms. So that change.
Yep, that's right. Yeah. Those are probably the main ones. So you can see that this is actually a much more robust and effective way of capturing meaning. And so on our next slide, we can see that the word embeddings also change throughout time. So it reflects, even though it's the same word, it reflects the change in meaning over time. So if we look at this one right here, awful, maybe in 1850s, is grouped more with solemn, majestic, awe. So it means probably something more like awesome today. But over time, it's sort of moved, and now it means completely opposite. So it means like something terrible, something appalling. So yeah, that's all the foundations up to there. Now we're going to talk about transformers and LLMs. So who here has heard of transformers or attention? Also what? Okay, so transformers are sort of the backbone of modern day LLM. So in 2017, Google researchers released a paper called Attention is All You Need. This sort of introduced this revolutionary new mechanism called attention. So what is that? The word embeddings we previously saw, these are, in a model, these remain static. So during inference, during the time that you're using the model, the embedding doesn't change, the meaning of that word doesn't change. But with attention, it allows us to have dynamic embeddings where the word moves depending on the context. So a really simple example of this is, let's say the word fly. So fly can mean things in different contexts. So to fly like in the sky, a fly on the wall as in the insect, and the word embedding that reflects the different meanings should be completely different, completely separate. Before we didn't have a really good way of capturing that, but now we do. So in the past, maybe you'd have two separate embeddings for the two different meanings, but then you'll capture things like in a certain context, that fly could be completely different. So let's say you had a really big fly, the fly embedding then moves more towards the dimension, towards the direction of big. Or let's say you had like a blue fly, then the embedding would move more towards the direction that meant blue. So the result of this is that we're able to capture context and we're able to capture like long-range dependencies within text much better. And they're the backbone of LLMs. So LLMs are transformer-based models that use attention, and their task that they're trained on is next token prediction. Tokens are essentially, if we're talking about text, tokens are subwords. So you might have a small word like a or the. Those would be tokens, but then you also, like, let's say you had a bigger word, such as underwater, then under and water might be split to two different tokens, or it could be underwater, 3 tokens. So yeah, those are all the foundational concepts. And closer towards today, this is how LLMs looked like just 12 to 18 months ago. So we contain hundreds of millions or even billions of parameters. So if we remember back to the neural networks slide, there are parameters sort of contained within each one of those nodes. We also pre-trained these LLMs on huge bodies of text. So we'll scrape that from the internet, from books, or anywhere. And the general way that we train these LLMs is like a three-stage system. So we start with something called unsupervised pre-training. So this is the part where we feed it that huge amount of text. And we don't provide any external labels. We just let it learn any patterns that it finds within that text. And then we move on to supervised fine-tuning. This is when we get human labelers to create, let's say, a question and then create an answer. And we want the LLM to learn how to answer questions in the way that humans want it to answer. Then we move on to reinforcement learning from human feedback. So if you guys have used ChatGPT, you may have seen sometimes that when you ask it to respond, it gives you 2 different responses and it asks you which one do you prefer. Has anyone seen that before? Yeah? That's an example of reinforcement learning from human feedback. Your decision in that point helps to train the model, helps to align it more to how you or how humans like the LM to respond. And also 12 to 18 months ago, OpenAI really was the #1 player. Well, some people might argue they still are, but it was really clear 12 to 18 months ago that they are the #1 player. It looks quite different today. So this is what it looks like today. Today, instead of millions, we have billions or even trillions of parameters within a model. We're able to do not only text, but also multimodal, so video, audio, input and output. We have something called reasoning capabilities, which I'll talk about later on, but it essentially allows models to solve complex sort of multi-step tasks that it previously couldn't. And we're also able to expand the capabilities of our model through things like tool use, so giving it access to web search or allowing it to use a coding platform. We also have so reinforcement learning, that last piece of the puzzle we talked about previously. It's now become a much larger part of model training. We also have things like computer use. So this is when you give your model access to your UI, allows it to click around, do simple tasks for you. We also have deep research, which, has anyone used deep research here? Has anyone heard of it? Yep. So deep research is where the model sort of recursively searches through the web to generate a report for you. And it might take 5, 10, 15 minutes to do so, but then in the end you get like a fully referenced report on whatever you wanted. We also have long context. So context window is how much text you can input at the start. We have models that are getting bigger and bigger context windows. So today I think the biggest one is probably, Facebook and Meta just released one of their new models just in the last week that has a 10 million context window. Prior to that, Google had a model with a 2 million context window. So there's a huge sort of leap in the capabilities, and it's happening very rapidly. The context window is also measured in tokens, not in words. We also have huge strides in image and video generation. So has anyone seen, OpenAI's 4.0 image generation recently, the one that creates all the Studio Ghibli like iterations of yourself? Yeah, so that one was really much better than anything that we had before. And we also have a lot of different players, so not just OpenAI, but we have Anthropic, xAI, Google, Meta, DeepSeek, etc. So it's not only American companies, but also many strong models coming out of China as well. So I'm going to talk a bit more about the reasoning paradigm. So previously I talked about reasoning. There is a bit of a misconception, I think, that models are just regurgitating content that they saw on the internet. So from their training data, they see they only produce things that they've already sort of seen, that's already out there. This is not strictly true anymore because of reasoning and because of reinforcement learning. So this is the general process of reinforcement learning. You would show a model a problem with a verifiable answer, so something like a maths problem or a coding problem. Then you'd ask it to produce a reasoning trace to get to the answer. So a reasoning trace is essentially just a step-by-step chain of thought that it uses to get to the answer. And if it gets the answer right, then you adjust the model so that it's more like that. And then you just keep repeating this. And what the result is reasoning models that are really good at problems that require you to do logical steps, step-by-step chain of thought reasoning. Just to illustrate the power of this, there's something called the GPQA benchmark. So this benchmark is essentially a way that we judge a model's performance in a certain domain. So this benchmark is a set of questions where we have field experts that can solve most of the problems. So there's like a few hundred questions in here. So field experts are people who are currently pursuing or they already have a PhD in the field. So 64.8% accuracy was their expert score. Non-experts can't solve most of the problems. So this is, they got 34.1% on the full benchmark, 22.1% on the diamond. So the diamond subset is the hardest questions for non-experts to solve. So even when they had unlimited access to the internet for 30 minutes. And by the way, the non-experts we're talking about are still people that have a PhD or are pursuing a PhD in another field. So it's not like they don't know how to use the internet or they don't know like any simple scientific sort of concepts. This is an example of some of the questions that we see on the benchmark. So you see we have really hard questions coming from fields like biology, physics, chemistry. In 2023, GPT-4 achieved 97 percentile on the American SAT, so these high school level problems. But on this benchmark, it could only do 39.4% accuracy. So because it's a multiple choice out of 4, 25% is guessing. So it's really not that far above guessing. Does anyone want to guess how well it performs today or this year? Not on the SATs, but on the GPQA. So previously it did 39%. 70%. Any other guesses? 60. Okay. Well, this is a chart of how well they do today. So this is on the diamond subset, the hardest subset. These four are some of the best models from the leading companies. They're doing above 80% on the GPQA diamond benchmark. And keep in mind, so these are all reasoning models. The first reasoning model was only released end of last year. And we already have, all the top companies already have reasoning models pushed out. So here's the kicker. So this is back to the previous slide. I said that during the process of RL post-training, you start with showing a problem that has a verifiable answer. The thing is, medicine is also a verifiable domain. So it's imaginable that we could get to this level through RL to really get superhuman performance in clinical reasoning. I say medicine is mostly a verifiable domain because sometimes there's sort of gray areas and there's not always like a certain right answer, but for the most part it is when you compare it to fields like arts, for example. And there's going to be a new release of reasoning models from OpenAI very soon, so in the next 1 to 2 weeks, and expect that the performance will probably be quite improved from the previous models. So yeah, with all that in mind, we're going to move on to see what the state of the art is in healthcare AI specifically now. So these are some of the domains I want to cover. So we've got medical Q&A, question answering, clinical decision support, medical research, biomedical research, patient education, and admin tasks. So firstly, we have medical Q&A. So this is simply like you ask, for example, multiple choice questions, medical students, entry exam questions, things like that. Not entry exams, but yeah, exam questions. I'm gonna go through this link. Oh. So has anyone heard of Hugging Face before? Anyone know Hugging Face? Probably just CJ again. So Hugging Face is essentially a platform where people can test benchmarks, so test the models on open benchmarks. It allows people to see which models are performing the best in certain domains. So we have a medical benchmark here. Hopefully it loads. Yeah. So here you can see a leaderboard of the scores of these different models on the medical question and answering. So we look here, we get quite high averages on the questions. So I think it's safe to say that for medical question and answering, LLMs have really come a long way, and in some cases they're even comparable to humans, or in some cases even better performing than humans. But there is a reason why this hasn't translated into the workplace that much, and we don't see like robots running medical practice yet. So this is where we get to clinical decision-making support. So these questions are not really reflective of how it is to really be a clinician and be in the workplace, and that's the reason why we don't have these models in the workplace right now. At least not making clinical decisions. They can help with other tasks. But for example, if we really wanted to help with a doctor's decision-making, there's a lot of fine-tuning often that needs to take place, and it happens in a specific domain. So for example, that top study happens in oncology. We don't have a general clinical reasoning model that exists yet. There was a study that was conducted by Google that showed that in some cases, so this is, they got LLMs and they got humans to generate differential diagnoses. They tested the accuracy, and they found that LLMs in this study performed better than LLMs plus humans. So when humans were using LLMs as an assistant. And it also performed better than the humans themselves. So this raised a lot of concerns as to what is going on. Are humans limiting LLM's potential in some cases? The limitation of this study was that it used case reports, so it wasn't really using real world, what happens step-by-step cases. But it does show that it's important that we sort of learn how to use LLMs effectively if we want to increase our clinical reasoning and our patient outcomes. The general consensus right now is that the current LLMs are not sort of ready for deployment into the healthcare system for autonomous clinical decision making because of issues like hallucinations, issues like liability. But they can help in a lot of other ways still. So in medical research, we have tools like Elicit or Deep Research. Has anyone seen Elicit before? Yep. So Elicit, you can use it to search the literature for you. I think these tools are really the start of something that we might see in the next five years probably, where medical research is really accelerated by the ability to for AI to sort of search through literature and get people to understand the overwhelming volume of studies that come out. And it really helps to sort of get evidence backing decisions when it's easier to access that evidence. In terms of biomedical research, we have AlphaFold. AlphaFold was the first Nobel Prize to be awarded to a project that was enabled by AI. So this, they got the Chemistry Nobel Prize last year. What their project does is you can feed it sort of the string of amino acids for any protein, and then it can predict the structure. So previously it would take years and years and PhD level researchers to sort of piece together the structure of even one protein. But with AlphaFold, they can do it super fast. And the implications of this in drug discovery are really like crazy. So that's why they got the Nobel Prize last year. And it's a really big step for, I think, AI research or AI-enabled research in general. We also have patient education. So if you think about LLMs, they have this natural ability to sort of interface with user through language. And they've been used to sort of summarize findings, create simple reports of radiology or condition diagnoses, and generate educational materials which are easily accessible and easily sort of produced. And in terms of admin tasks, we have sort of agents or models which help to reduce burnout, help to reduce hours by helping out with simple tasks like generating discharge summaries and sending off path reports, things like that. So yeah, as you can see, it's really super fast-moving field. So one of the questions is, how do you stay up to date with things coming out every day? So if you want to stay up to date, things like X are really good. So follow like big people on X, big companies as well. And then there's a lot of blog posts from big people in the space that help to take apart the latest developments and make them more accessible as well. So yeah, I think that's all from me. I'll pass it on to Isabella.
Hi everyone, I'm Isabella if you don't know me already. I'm a second year med student like some of you here, and you might have seen me around at some of the Nexus events. I'm one of the original co-founders of it. And I'm also an AI researcher, as Brian mentioned earlier, under Associate Professor Kwok Kao, if you do know him. So today, my part's going to be a tiny bit less technical. I want to stimulate a bit of a discussion with you guys about the current role of doctors alongside AI and where this is all going in the future. But before we do that, I'm also going to go through some of the challenges as well in implementing AI in healthcare. So before I do that, I want you guys to have a think and have a chat amongst yourselves about where you think the challenges are. And they can be the most general ones, from basically hallucinations to, I don't want to give away the answer yet, but have a chat amongst yourselves. Cool. Are you ready? Is someone brave enough to start the discussion? Anyone? Please.
Liability. So like if AI makes a mistake, who's really responsible for kind of amending the mistake? Is it like the company who made the AI?
Yeah.
Or like the people who made the AI, so like the software engineers or the people who put the data in, or is it the hospital, the lawyers? Who decides what has happening?
Absolutely, accountability. And we don't have any regulations in place for that either, which I will be covering. Anyone else?
Yeah, apart from that point, I think also upskilling the workforce as to how to use these correctly and all that is a big task, which will take a lot of time and effort. And yeah, as you said, there policy around it. How do you actually regulate such a thing, which is by nature so unregulated? That's a whole other thing, which will have a lot of shit to do with I guess like public health and lot of advocacy on that side.
Anyone else?
Awesome. So you guys actually, never mind. Go for it.
Well, we were just thinking about data privacy and stuff. When you're using a ChatGPT, how do you make sure that they're not using patient data to train their own models or just
Yeah.
leak it? Yeah.
Absolutely. Yeah, you guys touched on really big points that I all did actually cover. So we'll go through them one by one, but yeah, so that's what we're covering. There we go. Okay, so these are the main points. You guys already did cover a lot of them. So let's just go into clinical safety a bit more. We kind of already went through it, but what are medical hallucinations? It's basically when the LLM provides a false output. And this is a really common problem. Have you ever used ChatGPT and it literally just really confidently gives you the wrong answer? Like, obviously this is a really big problem when it comes to integrating it into a medical setting because you're dealing with real lives. And specifically some areas where this is a big problem is, for example, if you have incorrect triaging, inappropriate treatments, misdiagnoses. These are all areas where you can't afford to make a mistake. And that's why I guess we're still quite cautious and we're still quite slow in integrating AI. And on top of that, some other big points when it comes to clinical safety is the lack of robustness, and especially when it comes to the training data. In healthcare and medicine, there are obviously a lot of rare diseases, rare conditions, and you can't exactly train an LLM to cover all of these diseases, and you need to have really robust data to train them on, which we're still working on. And also the lack of explainability, which of course this is getting better over time. We do have companies like Anthropic working on explaining AI and actually going into, like, it's, the main term for it is that it's almost like a black box, that we can integrate rules into it, but we can't always 100% verify that it's always going to listen to us. We can only be 99% convinced, which is a tiny bit concerning when it comes to areas such as drug interactions and making sure that it gives you the right treatments and all of that. So these are all kind of things that we're still working on. Yeah, so another big point is bias and equity, which I feel like is quite important to touch on. This is being improved a lot quite recently, but AI, the data that it's trained on is usually historical data, and there have been problems in the past where potentially, unfortunately, specific groups in our population, AI is actually less accurate in diagnosing and treating these patients, or giving them certain diagnoses and conditions. And so it's not actually representative of our overall population. And so with less data in specific groups, you're going to be experiencing greater diagnostic uncertainty. So we actually need to work on the data that we're actually training these models on. And as already we've kind of discussed, how is responsibility determined when an AI makes an error? So of course we can't really sue a model, unless, I don't know, you sue ChatGPT or something. But the problem here is that we don't really have any regulations or laws that are currently put in place to kind of govern this sort of scenario, which of course in our current day and time is still very likely to happen. And that's why we're still obviously so hesitant. Another big one is ethics and consent. As we've been, all of us are medical students, we've had it hammered into us, informed consent and making sure that the patient is informed. And with AI changing so rapidly and so quickly, we need to be able to explain fully how we're using AI. For example, if you're a GP and you're interacting with a patient and you're using it to help you take your history notes, you need to explain that to the patient in a full and comprehensive manner to make sure that they can fully consent to that and they know what they're consenting to, which is often really hard when AI, the role of it keeps changing. So also as already mentioned, if you have started placements or have been to a hospital, we can tell how outdated the systems are in hospitals currently. So imagine having to integrate AI on top of that. So with that, you also have the issues of data privacy that have already also been talked about, and you're dealing with a lot of personal and sensitive info. And if there's a possibility of that info being breached. Of course, that's a huge problem. And so some stats that have come out recently show that nearly 1 in 4 GPs nationally are believed to use AI for note-taking, which is actually already quite massive. So we can see that it is quite useful, obviously, in a GP setting, in terms of helping a GP out in history taking and taking notes. But at the same time is how is this data being stored? How can we make sure that it's not going to be breached or hacked into or shared with the wrong people? So, yeah. And yeah, as I've already talked about a few times, we don't really have any comprehensive federal legislation that is currently put in place. Even in America, where they're kind of leading all of this and we're kind of following them, they don't have much. I'm pretty sure they do have a few laws from maybe 20 years back that they kind of try and hypothetically apply to now, but there hasn't been anything new that has actually been properly passed and established, which is obviously a huge problem considering the pace that AI is progressing at. So yeah, those are some of the challenges. Let's go into the next topic. So how is our role changing as healthcare professionals? So let's have a think about this. Some of the members of the Monash Medical Technology Lab have put together a very, very nice table for us to have a look at. Hopefully you guys can read it. If not, have a look at the screen behind you. But it covers basically 3 separate categories: performance, autonomy, and integration. And it also separates it into level 1 to level 4, with level 1 being competent and level 4 being superhuman. So let's go through each of them and have a think about, based off of what Brian has been going through so far and what I've been talking about, where do you guys think, what level are we at, for example, for performance of medical AGI? Where do you guys think we currently are? Have a think about it amongst, you guys can have a talk about it. Feel free to shout out which level you guys think we currently are at. Level 1, level 2, level 3. Also have a think about autonomy and integration, and then we'll come back in a few minutes and discuss all 3 of them. Yep. Are we happy to come back into discussion? Let's start with performance. Does anyone have any, there's no right or wrong answer here. This is all quite subjective. Level 2? Okay, we're getting some level 2s. 2, okay. Level 1, level 2? Wait, sorry, 2? Okay. Yeah, so of course this is quite subjective, but personally, I kind of went in between level 1 and 2 upon further discussion with some people, especially because we have a few, honestly you could argue, as you guys are saying, that it could be at level 2, but it really depends on the specific, on the specialty, and there's so many different subjective ways of kind of answering this question. But there was a paper that was released where a specialized medical LLM scored up to 86.5% on the MedQA dataset, which is kind of what Brian was talking about with the benchmarks. And it showed that physicians preferred the medical LLM's answers to those from physicians on 8 out of 9 clinical axes, which is a lot to think about. That's yeah. So let's probably go between level 1 and level 2. How about with autonomy? Yeah, we're probably still very much at the beginning because we haven't really deployed AI to autonomously make decisions by itself without any sort of clinician input. Like the way we currently use it, we have clinical tools such as IBM Watson Health and clinical decision support systems, and they only make suggestions, while we, as the clinicians, we always make the final decision. And integration? 2, 1, okay. Integration? Somewhere in between, because most AI systems haven't actually been deeply integrated into EMRs or clinical systems. We of course have some hospitals and startups. You might have heard of, for example, Heidi Health, like the medical AI scribe. They've been quite popular with GPs, as we could tell. I don't know if all the GPs are using Heidi Health, but it is quite popular at this current point in time. But what I'm trying to say is that most of them are kind of specialized small integrations within the medical setting rather than a general integration that covers a lot of different domains. So we're still very much in the beginning of the integration phase. Cool. Yeah, so let's go through the future of AI. A lot of this we can't obviously predict for sure. We don't know the rate. This is a very big question to answer. But there are some things that we are quite certain about that will happen over the next few months. But of course, the further we go, the less certain we are. Something interesting that was literally just announced a few days ago and I felt like was worth mentioning was AI. OpenAI's GPT 4.5 model passed the Turing test for the first time, which I'm not sure if you know about the Turing test, but it was basically this guy called Alan Turing, in the 1950s, pioneer of his field, kind of determined this test he created this test to determine whether basically an AI is as human as us. But of course, this test, there's a lot of flaws in it, but considering its historical significance, this is quite a large breakthrough because this is the first time this has actually officially happened. And so what the test actually consists of is having a participant chat with a human versus an AI. And then it basically has to choose which one's human and which one's AI. And it was found that on 73%, let me rephrase that. When OpenAI chatted with a human, it was deemed to be human 73% of the time, which is of course higher than the random chance of it being 50%. So obviously this suggests that the Turing test has been beaten. So yeah, that was something quite new. Moving on, yes, the future of AI. Where is this all heading? A really interesting kind of mini paper was released a few days ago called AI 2027. It's creating a lot of buzz within the community right now of AI. And it kind of goes through a certain timeline or a scenario about how things will unfold over the next few years. But let's have a think about the four main areas of focus that have are considered to be the main areas that we want to expand on and develop to be able to further progress with artificial intelligence. So obviously larger base models is a big one. We want more data to feed to models to train them on because that has obviously shown to produce better results, scaling laws. Teaching models to reason, as Brian kind of mentioned earlier, now AI models aren't just simply pattern recognition. We have reinforcement learnings and fine-tuning that happens after the original training, which teaches models to actually reason, and obviously this improves results a lot. So there has been a lot of work that is being put into that. Increasing a model's thinking time. Of course, a big thing with that is, of course, that's going to be taking a lot more compute, but that's also another big point. And you might have seen, when you use ChatGPT, you can sometimes choose kind of the level of how hard you want it to think, or you can tell it to think harder. But I guess that's kind of, that. And also building agent scaffolding for multi-step tasks. The main question, though, is how close are we to medical AGI and ASI even? And there is no clear way of answering this question because it also depends on how you define medical AGI. But we did have that really great table before that covers a few of those scenarios. Yeah, so forecast for mid to end of 2025. Main thing we're kind of predicting right now is that we're going to have AI agents go mainstream. So what they'll be doing is they'll be able to autonomously handle complex tasks like bookings and data entry and scheduling and writing. And you can basically ask it to book a flight for me at 7 a.m. this day, and it can kind of do it all by itself. Another big thing is, of course, if we have AI agents coming in, there could be potentially some assistance within clinical admin work that could be implemented through this. And also, there's going to be a big focus over the next few years, I believe, in focusing on using AI to actually boost AI research. So if you're using AI to actually help improve on itself, then of course that's going to lead to almost an exponential growth. At least that's what we're expecting for what to happen. So that's going to be a really, really big point of how the next few years progress within artificial intelligence. In 2026, we're expecting there to be like full coding automation, that basically coding like AI, if it isn't already, will be better than basically almost all coders, maybe, I don't know, the top 1%. And potentially, few further improvements for internal AI. So again, going back to using AI to boost AI research, a really, really important area of focus. And I did also mention geopolitical tensions. China, of course, we've maybe some of you guys have heard of DeepSeek. It was a model that was released, and it's clear that potentially, if we haven't already entered one, we might be entering an AI arms race, which is obviously a big thing. And when we think of Taiwan and we think of the chips that are produced there, that actually might be a contributing factor to China. I'm not going to be speaking on political matters here, but you can figure that one out yourselves. But obviously, as AI further progresses and governments and the military and the defense figure out how useful all of it is, and how we can it can start undergoing a further exponential growth, we might be entering a sort of intelligence explosion by the time of 2027, where I think, Brian, you mentioned earlier about how we can use AI, and even when we think of AlphaFold, the Nobel Prize winners last year, how they were able to use AI to really speed up their own research. So obviously we expect these algorithms to keep improving exponentially. And so by 2027, we might be starting to answer and research a lot of the domains, and we might start addressing a lot of those research questions that weren't able to be previously answered because they could take years to process all the data and to produce those algorithms. But now, because of how further advanced these models are becoming, we can potentially do that. What else? A global arms race, kind of already mentioned that. And as I've mentioned, continuous reinforcement learning. So if we get AI to continuously self-learn, it basically keeps improving on itself even when we're sleeping, and it's able to keep doing research on itself, on other sectors. It's a lot of stuff happening. So that's why we're expecting it to keep growing and growing. 2028 and beyond, obviously a lot of this stuff is quite uncertain. A few things that potentially might happen is that we might have expert level knowledge in almost every field. Because of how fast and efficiently AI can conduct research and answer any research question we might have. And also, probably by that point, are definitely better than humans at coding, and potentially have general reasoning skills better than almost all humans, which currently it's more lacking in, because it has trouble with longer context questions and inputs. And potentially, as I've been talking about, it'll be working while we're sleeping, so it can autonomously complete many day-long tasks on a computer when we're resting. So a lot of big things happening. So that's kind of a little overview of kind of like the drivers of progress that I did basically touch on all of them. So you can have a read of that once we send through the slides. We've kind of already discussed what our current role is alongside AI. I want you guys to now have a think about what will our role becoming. And there's no right or wrong answer here because I don't even know myself. So have a think about it.
Alright, so we were kind of discussing how AI is so much more efficient than us, assuming that it is accurate in the first place. So we're not quite sure exactly how far into the future we'd be discussing, but we were thinking that maybe there'd be a point in time where we aren't actually seeing patients ourselves, but instead we're kind of in the sweatshop training AI to do it for us. Because if you think about it, in the time that we can see one patient, the AI can probably do like countless patients, just because it can be in multiple places at once, dealing with multiple inputs. So we were kind of thinking that it's just more efficient for us to be training the AI to do our job for us. But then again, that's like probably very far from the future, or it might be closer than we think. We're not quite sure.
Really great points. That's okay. I've only mentioned a few points just for general discussion. It's more to just stimulate having just have a think about it, because again, a lot of this, obviously, we have no idea what's going to happen yet, and at what speed we're going to be integrating all of this. So some of the things I did mention, which Johanny that you just talked about, was instead of performing tasks ourselves, we might be instead training AI and specific medical LLMs, because obviously they're a lot more efficient than us, even currently, in a lot of different domains. And once we train them, we might actually become supervisors of these AI outputs, because, of course, I don't think anytime soon we're going to be at a stage where we can fully trust AI and not check over any of its findings or how it's treating patients. I don't think that's definitely not anytime soon. But what might be sooner is that we might be supervising what they're doing, and they're going to be helping us out a lot. So we're instead going to be in charge of basically error detection and at the actual clinical judgment behind all of it, and actually making sure it's being safely used. Other than that, obviously, if you, for example, you're a GP and you're working by yourself, instead of becoming only the sole source of knowledge, you're also just going to become an interpreter of a lot of different sources of information, and you're going to be working with a lot more. And even if you're in a hospital and you're already working with other healthcare professionals, you're now also going to be a collaborator in an AI augmented system. So obviously, you're not going to be an independent clinician anymore. You're going to be, working with AI. And on top of that, I think a really big point is that how can patients actually trust AI? And obviously at the pace that we're moving at, a lot of people are hesitant and actually fearful because they don't exactly know how AI works, and they just think of the dystopian movies and that AI is going to take us over. I don't know, maybe one day that'll be true. But at this current point in time, if we do start integrating AI into the healthcare setting, we're going to have to be basically that mediator in making sure that patients can actually still trust us, and ensuring then that AI is actually helping improve their quality of care. So yeah, I guess those are just a few points of discussion. But yeah, and that's it from me. So I'll pass it on to Deepak.
Alright, in the interest of time, I'm gonna quickly show you guys one thing. So if anyone needs to go or has somewhere to be, you guys can. So this is, we have a medical AI journal club. So this is a group of doctors and medical students as well, who sort of gather around once a month to discuss anything new, any new projects people are working on, and any interesting literature. Importantly, in May 16, we have Meng Law, who's the Director of Radiology and Head of iBrain, and Alfred, who's going to come talk to us about radiology AI, which is quite big. And at the AI bootcamp we held last year, he came to speak as well and showed us like the prototype for Harrison AI, I think. And he has very strong opinions on AI, so I think you might want to share that, especially if you want to go into radiology. So. My talk is essentially on AI for learning. So broadly, it's sort of like, well, we know all this about AI. What can we do right now to help ourselves as medical students? And I do like education, and I think it's probably the highest yield thing anyone can get good at. A bit about me, I finished my honours year in medical learning at Sierra, so that's the Centre for iResearch Australia, and also did some projects with QA. Working on sort of clinical reasoning with LLMs, and also building a few education tools, which again at the end I was gonna like talk about it, and also if anyone's interested in working on it with me, this is sort of like a plug/pitch. So you get to I'll support your CS education and AI education while we can sort of work on something cool that will be open source. So also anyway. So my honours year project, it was sort of just for fun. I was like, oh, AI sounds cool. And then I realized, wait, like it actually has so many implications for the way we practice medicine, and the future of even biology will change. This is a paper called Mind-Eye. Essentially, they've managed to replicate or sort of deduce what a human is looking at by looking at the fMRI image. fMRI is functional MRI. It sort of tracks how the blood is flowing in the brain. So it's not, like, it doesn't really make sense how it even works, right? Like, I'm basically saying if I look at your blood vessels in your brain, I can backtrack and figure out you're looking at a fire truck. It's like, it's crazy. And this is, I think, like, we are only beginning to explore like sure you can get LLMs to do doctors' jobs, but like the more exciting things is sort of like, wait, can I, from these blood tests / these super niche like things that people never do, can we discover a new subtype of disease that we didn't know existed? And then can we figure out what the medication is for that, right? Or can we completely invent new ways to treat disease? Yeah, and more practically, like this is me talking to Claude and trying to get it to teach me. So it's like, and it does a really good job. I'm using a lot of acronyms. This is medical jargon. It's handling well, and importantly, the last line, it's like, it's querying me, right? It's like asking me questions using Socratic dialogue to get me to reflect on my understanding, and that's really what learning is. And I'll walk through how you can get this for yourself. Yeah, so broadly speaking, with AI becoming popular, there's been this explosion of tools. Perplexity, which is a search engine better than Google. Notebook LM, which is from Google, which sort of turns your notes into podcasts if you want. You get a whole bunch of coding tools, so you can get sort of a software engineer in your pocket. You got Elicit, which is the research one, and then Research Tribe, which is one of the buddies. You've got a whole bunch of medical AI companies that have popped up, and I think I spoke about Harrison just there. We've got a few writing editors, so if you want to learn how to write or like improve the way you write, you can write a whole bunch of slop and then it delivers this beautiful prose. I want to talk about two main things: learning in the post-AI world and problem solving in the post-AI world. Learning, anyone know these people? Yeah. I think there's a guy called Ali Abdel there. There's also Justin Song. There's deep work by Cal Newport. There's a whole bunch of different ways that I think like the side of YouTube about how to learn and learning to learn explores. And I think that, yeah, this is just a slide talking about like the learning theories out there. But I think it's honestly one of the most important things to get good at, especially in this world where we have LLMs that are possibly, like arguably good at learning as well. And which means the nature of how you learn needs to adapt. So I'm going to deliver sort of like, I'm going to break down what learning is and talk about specific AI tools that will sort of hopefully enhance your learning in medical school. Learning, I broadly break it down to understanding and recall. Understanding is sort of making the fishbone, right? So before you put the meat on the fishbone, you want to understand what the fish is, where it came from. This analogy is falling apart, but so you like importantly, like if I give you some paragraph like that, and you want to learn, 21 hydroxylase deficiency impairs conversion of this to this. The classic rote learning method of the way we generally sort of lazily learn medicine, which is turning to an Anki flashcard, is very appealing, but doesn't really offer any understanding, and recall suffers as a result, right? Because like you don't know what's happening. Alternatively, this is so much more appealing, especially to me. So I want to learn this, teach this to me, right? And then it's like, oh, okay, what do you know right now? And then that sort of forces you to creatively reconstruct what you think the cortisol system is. You can correct your misconceptions, etc., etc. There are two key tricks that I think I want you guys to take away, no matter what you take away. One is reliable in-context knowledge and prompt engineering. We know that LLMs obviously have some tendency to hallucinate in that they deliver information that might not be factually accurate, but it is known that if you put in the context window, meaning before you tell it to do something, if you give it the information you want it to rely on, the hallucination rates plummet. So this is a summarization task. So it's basically someone who just gave chunks of text and told an LLM to summarize it. And the latest ones, which are particularly the reasoning models. So typically, so this is a reasoning model, this is reason, like these three, I think these are all reasoning models except for this one. But they have a high, they have a very low hallucination rate. Meaning, I honestly, like if you ask a consultant, like the hallucination rate is higher than that, right? Like I think you can sort of rely on it, to be honest. Prompt engineering is the idea that you can deliver this set of instructions to your model and it will change the behavior. So this is the, like you have to scroll down, but this is sort of the project instructional prompt I have for mine. And there's just a whole bunch of other stuff, like you can say engage in Socratic dialogue, which is just like ask me questions to make sure I understand stuff. Ask guiding questions, don't offer answers, make sure that whatever you do, like don't tell me the answer, sort of thing. Or offer relevant clinical scenarios so I can actually learn in context with clinical medicine, which is also like people don't like that in preclinical medicine, for example. And And if you combine that together, let's say I put the curriculum or what I need to learn in the in-context window, and then I add the prompt of like, at each response, track aspects of the curriculum that are being covered and ensure that whatever you tell me is within the scope of what I need to know. And that automatically changes the behavior of the model to be guided by what you need to know. And yeah, it's like sort of having your own tutor. But importantly, what I'm basically telling you is the building blocks of this tutor, right? You don't need to pay like some random AI tutor, which is realistically just doing this, which you can do by yourself and make it more customized and make it better for yourself. You know what I mean? Yeah, and then ultimately, I want you guys to like hopefully build pipelines that help you make learning work for you. So this is what I do when I make pass-med questions. Or like when I do pass-med questions. I just spend like a few minutes with incorrect answers, use voice chat, and then have explanations in context so you can see what I'm looking at. And yeah, I think Brian mentioned this earlier, context windows are becoming bigger, so Llama 4, the latest model, there's more nuance here, but theoretically it has a high context window. So that's like 20 books you can put in there that it can rely on in context. So, okay, this is meant to be interactive. This is Ninja Nerd Lectures, right? If you guys know this guy. Antibiotics, it's a 2-hour lecture. How will you learn this content? Any ideas?
As in me personally, how would probably put it into flashcards or summarize it in some way, or maybe annotate pre-existing lecture notes. You can add his inputs into it, something like that.
Yeah. Wait, when you say summarize, are you using like some large language model?
I typically use like ChatGPT to help me summarize stuff, and then annotate those summarization, like those summaries sometimes.
Yeah. Nice. Cool. Any other ideas? Hey, you know, for this table, we guys haven't started yet. Sorry, I don't want to pick on you. Wait, I picked on you last time.
Unbelievable.
Okay, yeah, so like you first can think about like what you want to use, right? So Gemini from Google currently has a pretty good context window. It's like 2 million for the latest experimental model that just came out. I don't use ChatGPT for that reason. Like what I would personally do, so there's like theories of learning. One important thing is that you can pre-learning to build a skeleton of like the structure of your knowledge is important. And then in order to do that, you can, what people like to do is like watch the video in 3 times speed and you sort of focus on building what an internal map of the content is. I like to do practice questions and suck at them, right? Because then I know that like, I can sort of remember, or I can see sort of the logical conclusions between concepts. And I think it's an underrated technique. And then in the understanding, I like to build a set of learning objectives or whatever is in the curriculum, put it in context in LLM, and then do everything we talked about. So this is Gemini. Because they have YouTube, like Google owns YouTube, you can actually put in YouTube links and it can read, I guess, like, or watch the YouTube video for you as well. So this is a huge prompt, which sort of includes everything. There's like more above it. But yeah, so it's gonna build learning objectives for me. It's going to propose it, and then it's gonna say, let's like, do you want to start with the first one? And then it starts off in a very like Socratic way, which builds my understanding from fundamentals, which I like a lot. Again, this is not a prescription. I want you guys to figure out what works for you, but this is something I like to do. Okay, next thing. So we said that broadly you can categorize things into understanding and recall. How do you guys recall content now? Like, I think you mentioned flashcards. Yeah. Well, what do you guys use for flashcards? Yeah, thank you.
Just get ChatGPT to make questions off my notes as well.
Yeah, nice. Any other apps or like anything? Yeah. Okay, sorry. I'm a Remember chill because I love it. But yeah. Anything else? I think those are the 2 that I know of. Yeah. So essentially, spaced repetition is evidence proven like that it's really good for learning. For recall and for memory retention. So I like to use RemNote. So RemNote is an app that also has a lot of AI integration, which I think they're doing really well in, honestly. But the idea is that you can make flashcards while typing. So like for example, I would be typing deconditional heart failure, what's the EF? And then if I hit double arrow, it automatically makes that flashcard there. So it's a nice way to make notes and flashcards at the same time. And then obviously revision questions is another part of doing good recall. Yeah, so like this is me hovering over like some note that I took, and then on the right hand side, that's like the preview of the flashcard. Yeah, and another cool feature is that I'm studying for the BPS, like the path exam right now. So you can make it schedule for making sure your retrieval is maximized at a specific time point, which is probably like around the exam. And yeah, PassMed, eMedici are like common exam questions. So as you guys can tell, there's actually just a set number of tools that if you get good at, you can build these like interesting and useful pipelines for yourself that you can customize, right? So essentially, I'm just prompting using in-context stuff, and then doing some few-shot examples, which is just setting examples in the prompt of what I want the output to be. And the rabbit hole goes really deep. So you can add new tools. There's like model context protocol, where maybe your model can query and search through PubMed and get reliable results and put that into context window as well. You can use multi-agent frameworks, which are shown to improve clinical reasoning, and structured outputs, and convert them to flashcards if you want. There's a whole host of new things that can be done. Yeah, that's from it. So I want to sort of touch on problem solving now. So this is the second part of the talk in a way. So one big problem that I faced in Frequent like 2 years ago or 3 years ago is like I make my flashcards I make my notes in OneNote because I can draw, but I can't convert them to Anki cards because it's not an Anki card. Like I have to manually make it again, right? Like that was such a time sink, and I hated like every single moment I would like try to recreate my flashcards. And what I want to tell you guys is that now, with the ability to use, there are a lot of problems, right? Much like this one, Monash, I think they were speaking about trying to replace PebblePad, which is the sort of logbook system that clinical students currently use, which kind of sucks because it isn't built for purpose. So there's actually a whole host of problems that, like small problems that previously were not financially viable for someone to spend money to build, which all of a sudden we can build relatively quickly and cheaply. The way I like to think about coding is essentially you're distributing problem solving, right? You're solving a problem and you're able to share it. And the cost of coding is super cheap now, which means the cost of problem solving is super cheap. So, for example, you can pump out a PebblePad alternative that really focuses on medical students and the specific needs they need in maybe let's say 3 weeks if you haven't coded before, which is still crazy, like 3 weeks if you haven't coded. Or like a week if you've coded apps before, or like a few days if you've coded a lot of apps before, right? Oh yeah, so this is my little solution. So this is a OneNote to Anki converter that I made. And this took me like probably a week because I'm not super duper old. I mean, I'm not very, very experienced, you could say. But it's an automatic way to convert from OneNote notes to Anki flashcards. And yeah, that's the website. So like the notes on the left and then converts into flashcards on the right. Obviously, work in progress. If anyone is interested in working on this, we can go halfsies on any buddies, mate. But like, I don't really care about that. But yeah, because this project will probably die because I don't have time to work on it. You know what I mean? But I'm happy to help out, and it can be a good experience to also learn computer science and basics of coding. Yeah, and this is another project which is essentially the idea is that it's learning on words is very unproductive. What if we can make it better? That's the thesis essentially. If you guys want to learn how to code and want to learn everything about AI, hop onto our Discord in Nexus. If you guys want to work on any projects, so for example, someone in MMTL was working on like they want to look through photos and try and identify their face in it because they just had a whole bunch of photos and it was like these are all from like different events, and like I don't want to sit through like 500 photos of other people that I don't really care about. So and he built it and it was using deep learning and like worked really well. So that's quite cool. So there's people working on cool stuff. So you can hop on the Discord, find a small group of people you want to tackle a problem with. Also, the Intro to Programming is a course run by the MedTech Lab, running this year in a few months. Yeah. So keep an eye out for that, and that'll be a good intro if you don't know much about programming or want to just learn more about it. Yeah, and this is what I was mentioning earlier. Yeah, that sort of concludes what we wanted to share with you guys. If you guys have any questions, raise your hand. We can go around the table. Otherwise, please fill out that feedback form. And yeah.